Yeah, hello everyone. In the previous video, we are discussing this question. Okay, it hasn't completed. Let us continue this question. So, from these, you can understand that 4 grams of H2 reacts with 32 grams of O2 to form 36 grams of water. So, from the balanced chemical equation, we can understand that 4 grams of H2 reacts with 32 grams of O2 to form 36 grams of H2. Now, let us first find the limiting reagent. Okay, based on the limiting reagent, we can find what is the amount of water that gets produced. Okay, let us see 10 grams of H2 is given, 64 grams of O2 is given. So 4 grams produces 36 grams of water. 4 grams is producing 36 grams of water. Then 10 grams will produce how much? Let us see this as X. Then cross multiplication, when you cross multiply, you will get X is equal to 10 into 36 by 5, which is nothing but 90 grams. So 90 grams of water will get produced when 10 grams of H2 reacts with oxygen. In the same way, let us find what is the amount of water that gets produced when 64 grams of oxygen is reacted. From this we can understand 32 grams of O2 reacts with 32 grams of O2 produces 36 grams of water. Then 64 grams of oxygen will produce how much? Now if you see 64, it is double of 32 only, no? Then the amount of water that gets produced will also be double of this. Even if you cross multiply also, you will get the same answer, which is nothing but X will be equal to 72 grams. So 72 grams of water will get produced. So what is the limiting reagent? What I said? A reactant which limits the product. We call that as limiting reagent. Here if you see 10 grams of H2 can produce 90 grams of water. But 64 grams of water is producing only 72 grams. So which is producing the least amount of product? 64 grams of oxygen. So that is our limiting reagent. Okay. So here he is not asking the answer in grams. He is asking the answer in moles. What is the amount of water? Okay, he is asking that in moles. We know that molar mass of water, it is nothing but 18 grams. Okay, 18 grams will represent 1 mole. Then 72 grams will represent how many moles? Let us think that as X. If you cross multiply, you will get the answer. So X is nothing but 4 moles. Okay, simple question. So the answer will be 4 moles. Okay, please check. Okay, let us see the next question. See, the number of water molecules is maximum in. He is asking us in which of the following the number of water molecules are more. Option A, he has given 1.8 gram water. Option B, 18 gram water. Option C, 18 moles of water. Option D, 18 molecules of water. Okay, in which the number of water molecules is more, he is asking. Okay. So to find that, first let us see the molar mass of water. Okay, H2O. You know the molar mass of H2O is nothing but 18 grams. Okay, I am converting these grams also into moles so that I will be knowing which will have more number of molecules. Okay, let us see that. Let us see that. Okay, here 18 grams, if you see, it represents 1 mole. 18 grams represents 1 mole. Then 1.8 gram represents how many moles? 1.8 is 1/10 of 18 only now. So it will be 0.1. Is that right? So 1.8 grams represents 0.1. So in the same way, in the option 2, he has given 18 grams water. Nothing but it represents 18 grams will represent 1 mole. Okay, and 18 moles of water he has given in option C. In option D, he has given 18 molecules of water. He has directly given the number of molecules. Okay, so if you see now, okay, so 1 mole of any substance will represent how many particles? Avogadro number of particles. Nothing but if you see this 1 mole, it represents 6.022 into 10 to the power 22 molecules of water. 0.1 mole means it is 1/10 of 1 mole. Nothing but this 0.1 mole represents 6.022 into 10 to the power 22 molecules of H2O. Next, 18 moles of water. What do these 18 moles of water represents? How many molecules? 18 into 6.022 into 10 to the power 23 molecules of water. 18 molecules of water. From this you can easily understand now which has the highest number of water molecules. 18 moles of water. So why I have converted these grams into moles means, okay, if you convert them into moles so that you can correlate. It will be easy to relate the other options, and we can get the answer. Okay, so option C will be our answer. Please take that. Let us solve the next question. Okay, it is nothing but question number 6. Let us solve. See the question: how many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar HNO3? So to prepare 250 ml of 2 molar HNO3, okay, what is the amount of nitric acid that is required? He is asking, and he is saying that the solution is 70% concentrated. It is not 100% concentrated. It is 70% concentrated. Okay. So first let us find for 100% concentrated, and then we will see for the 70% concentrated. Okay. Let me give the options also. Okay. If you see the options. Option A, 90 gram concentrated HNO3. Option B, 45 gram concentrated HNO3. Option C, 60 gram concentrated HNO3. And option D has given 54 gram. 54 gram concentrated HNO3. These are the 4 options. Okay. Let us first calculate what is the amount of HNO3 required. Okay. Nothing but we need to use the formula of molarity now. So what is the formula of molarity? Molarity is equal to given mass by molar mass into 1000 by volume. If volume is given in milliliters, we need to use this. Here if you see, he has given the volume in milliliters, 250 ml. That is why I am taking 1000 in the numerator. If he has given the volume in liter, no need to consider this 1000. Okay. So here we need to find the given mass. Nothing but the mass of HNO3 we need to find. Molarity he has given in the question 2 molar. Okay. Molar mass of HNO3 we can calculate now. Okay. HNO3 molar mass we can calculate. Hydrogen 1, nitrogen 14. Oxygen, each oxygen 16, 3 oxygens. So total it will be 15 plus 48, 63 grams. This is the molar mass of HNO. Substitute. Okay. So we will get 2 is equal to, we don't have a given mass, x we need to calculate. Molar mass 63 into 1000 by volume is nothing but 250. So 24. 2 2's. So x is equal to 63 by 2, which is nothing but 31.9 grams. So this is the mass of HNO3 required. Okay, nothing but if HNO3 is 100% concentrated, the mass required is 31.5. But he is saying the concentrated acid is 70%. 70% means it should be more than this amount. So from the given options, we can get the answer. Amount is, okay, which is when we take 70%, okay, which one will give us the amount of 31.5 grams? That is our answer. Okay, we can check it. When we consider 90, okay, 70% of 90 means 70 by 100 into 90. Okay, so it is giving 63 grams. So this is not our answer. Okay, in the same way, let us see 45 grams. 45 grams means 70 by 100 into 45. Let's cancel. Okay. So 7 into this 10 means it will be 4.5. 7 into 4.5, which is nothing but 31.5 grams. So this is our answer. Okay. Simple question. So here he is asking us to calculate the mass of HNO3 required, and he is giving one condition, that is nothing but the concentrated acid is only 70%. Okay, first I have found for 100%. I got this amount. Since it is 70%, it will be more than this. So from the given options, I have taken which is 70, for which if I take 70% will give us the answer. Okay. So when I consider 45 grams, it is giving me 31.5 grams. So that is my answer. Now let us see the next question. Easy question. The question looks big, but it is an easy question. Okay. See, suppose the elements x and y combine to form two compounds xy2 and x3y2. There are two elements x and y. They are forming two compounds xy2. The other is nothing but x3y2. Okay. When 0.1 mole of xy2 weighs 10 grams, he is saying 0.1 mole of xy2 it weighs 10 grams, and 0.05 mole of x3y2 it weighs 9 grams. So what are the atomic weights of x and y he is asking. So x and y they are combining together to form two compounds xy2 x3y2. 0.1 mole as a mass of xy2 has a mass of 10, 0.05 mole of x3y2 has a mass of 9 grams. What are the atomic weights of x and y? Let us see how to find this. See, 0.1 mole of xy2, it has a mass of 10 grams. So we can relate these two 1 mole so that we will be getting the molar mass of xy2. Okay. So 1 mole of xy2 has a mass of 100 grams. Is that right? 1 mole is 10 times that of 0.1 mole. So it will be 10 times. Okay. So the molar mass of xy2 is nothing but 100 grams. So this can also be written as molar mass of xy2 can also be written as atomic mass of x plus 2 into atomic mass of y is equal to 100. We can write it this way. In the same way, if you see 9 grams, see 0.05 mole of x3y2 has a mass of 9 grams. It has a mass of 9 grams. Then 1 mole will have a mass of, if you cross multiply, you will get the answer. Let us take this as x. X will be equal to 9 by 0.05, which you will get as how much? 180 grams. You will get that as 180 grams. So if you get confused, okay. Here, let us think this as A. So A is equal to 180 grams. A is nothing but x3y2. Okay, molar mass of x3y2. x3y2 is equal to 180 grams. Okay, nothing but this can be written as 3x plus 2y is equal to 180. We can write it this way. Is that right? Now, what I do is, from the first equation, I can make 1 and 2 in this way. First equation I will do in this way. X is equal to 100 minus 2y I will make. Okay, I will substitute this value in the second equation. Okay, if I substitute this x value in the second equation, what I will get? Let us see. I think we can take this. Let us see. I am substituting this value in the second equation. 3x plus 2y is equal to 180. So 3 into 100 minus 2y plus 2y is equal to 180, which is nothing but 300 minus 6y plus 2y is equal to 180. So which is nothing but 300 minus 4y is equal to 180. Okay. So 4y is equal to 120, y is equal to 30. So atomic mass of y is 30. If you substitute this value in x plus 2y is equal to 100 now, let us substitute in that. X plus 2y is equal to 100. Y is nothing but 30. So x plus 2 into 30 is equal to 100, which is nothing but x plus 60 is equal to 100, x will be equal to 1. So the answer will be 40 and 30. Atomic mass of x and y. X and y are 40 and 30. This is our answer. Okay, easy thing only. Let us see this question. What is the mole fraction of solute in 1 molar aqueous solution? He is asking us to calculate the mole fraction of solute in 1 molar aqueous solution. See, what is the formula? Mole fraction of solute is equal to number of moles of solute by total number of moles. Okay. So here to calculate mole fraction of solute, we require number of moles of solute, total number of moles. Number of moles of solute we has been given. Total number of moles we has been given. How to solve this question? He has given it. That is nothing but 1 molar aqueous solution. What is the meaning of that? 1 mole of solute is present in 1 kg of solvent. That is the meaning. So from this we can understand number of moles of solute is nothing but 1 mole. Okay. But what about solvent? What is the solvent here? Aqueous solution he is in. Nothing but the solvent will be water only. Is that right? So we know 1 molar aqueous solution means the mass of water will be, what is the mass of water? Mass of water 1000 grams, because what is the definition of molarity? Number of moles of solute present per kg of solvent. Okay, kg means 1000 grams. 1 molar aqueous solution, 1 mole of solute is present in 1 kg of solvent. That is the meaning. So mass of water we got. So number of moles of water is equal to mass of water by molar mass of water. Molar mass of water is 18. You know that. So we will get these as 55.5. So 55.5 moles of water is present. So the number of moles of water is 55. So from the number of moles of solute and number of moles of water, we will get the total number of moles of Nt is equal to number of moles of solute plus number of moles of water, which is nothing but 1 plus 55.5, which is nothing but 56.5. So these are the total number of moles. So we can substitute now. This is equal to 1 by 56.5, which we will get as 10 by 565, which we will get as 0.017. We can calculate this. So the mole fraction of solute is 0.017. That is the answer. You can take this. Let us see the next question. The number of moles of hydrogen molecules required to produce 20 mole of ammonia. So he is asking us to calculate the number of moles of hydrogen which are required to produce 20 moles of ammonia. Nothing but we can make a reaction between hydrogen and nitrogen. How ammonia will produce? When hydrogen reacts with nitrogen, then only ammonia will produce. Let us make a reaction. Okay. Nitrogen on reaction with hydrogen produces ammonia, NH3. So this is the reaction. So from the balanced chemical equation, we can understand that 1 mole of hydrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. From this we can understand every 3 moles of hydrogen will produce 2 moles of ammonia. Then 20 moles to produce 20 moles of ammonia. Okay. How many moles of hydrogen is required? Let us think this as X symbol then. So if you cross multiply, you will get the answer now. Is that right? So which is nothing but 2x is equal to 20 into 3. X will be equal to 30 moles. Is that right? Simple, easy question. Okay. Please take it. So remaining questions will be continued in the next class. Okay, please watch the next video. Remaining questions will be continued in that. Thank you all. Okay, so if you like the videos of mine, please give a like, please subscribe. Okay, please press the bell icon to get the latest notifications. Thank you all.